So in this video, we'll discuss about what is GCD and what are Coprime numbers. So we all discussed from our school days that is LCM and GCD, right? You know GCD service called a HCF, highest common factor. So the greatest common divisor GCD of any two integers A and B is the largest integer that divides both A and B, which is mathematically given as GCD of A comma B equals maximum of K such that K exactly divides A and B. So this is the largest factor, common factor or divisor which divides both A and B. And also we will further learn about Euclidean algorithm to find GCD of two integers. And here, another, you also know that GCD of A comma 0 is number A itself. And it is the number, if GCD of minus 3 comma 0, it is GCD of, if I'm asking GCD of minus 3 comma 0, it will be only 3. So the negative symbol should be ignored here. And GCD of A comma B is equal to GCD of minus A comma B, GCD of A comma minus B, which is equal to GCD of minus A comma minus B is equal to K. We have a GCD of A comma B, then it is applicable for minus A minus B or both are not. It should be a positive integer. Okay. And let us find the GCD of two numbers. We have taken the example of 18 and 12. Just recall what we did in our school times. We write the factors. Yes. The 18 can be decomposed into 1 into 2 into 3. This is using the prime factorization method and factoring using prime numbers. And 12 can be written as 4 into 3. That is 1 into 2 into 2 into 3. Now I am going to identify the common factors. Here I am having 1 and 1. Here I am having 2 and here I am having 2. Here I am having 3. Here I am having 3. So what are the common factors? 1, so we are having 2 and 3. So 1 into 2 into 3 is the common factors. So the highest common factor is 6. So GCD of 18, comma 12 is 6. Now, in this example, I have taken as GCD of 55, comma 22. 55 can be written as 1 into 5 into 11 and 22 can be written as 1 into 12 into 11. Here the common factors are, the highest factor is 11. Am I right? 1 into 11. It is 1 into 11. So GCD of 55, comma 22 is 11. Now let us take another example. GCD of 8, comma 15. So in a decomposed 8, I am getting 1 into 2 into 2 into 2. Whereas 15 is 1 into 3 into 15. So when I identify, there is no other numbers common between both 8 and 15 factors. Only one is there. So here GCD of 8, comma 15 is 1. Similarly here GCD of 10, comma 11. 1, 10 can be written as 1 into 10, 11 can be written as 1 into 11. The greatest common divisor is 1. Let's see what is about co-prime numbers. We all know about prime numbers. Co-prime numbers, a set of numbers that do not have any common factor other than 1. So for a co-prime number, minimum I should take a pair of numbers. I should have a pair. For prime number, I can claim that A is the prime number if I have only the factor is 1 and A. Then A is the prime number. So here for co-prime numbers, I should have minimum two numbers. I should have a pair of numbers. So, but let us consider the example 5 and 7. Factors of 5 are 1 and 7. Factors of 7 are 1 and 7. Here factors of 5 are 1 and 5. When you take that, the common factor is 1. So, I can claim that 5, comma 7 is a co-prime numbers. Let us take the other example here, 22 and 11. 22 can be written as 1 into 2. The factors are 1, 22, 11 and 22. Right? Because I can write 1 into 22 also 22 or 2 into 11 also 22. So this way I can have the factors. So here, but 11 is 1 into 11. So when you take the common factor, the largest common factor is 11. So the common factors are 1 and 11. Other than this, so the common factor is 1 and 11, so it is not a coprime. But when you take this 5 and 7, the common factor is only 1. So when two numbers, as per the definition, the set of numbers that do not have any common factor other than one, it should have only one common factor, that should be number one. Then only it is to be co-prime numbers. And we can use the GCD to check whether the given pair of numbers are co-prime or not. If GCD of A comma B equal to 1, then I can claim A and B are co-prime numbers. Okay. We already discuss and find out GCD of 8 comma 15 is 1. So 8 comma 15 is co-primes. Similarly, GCD of 10 comma 11 equal to 1. So GCD of 10 and 11 are co-primes. And let's learn some fact about the co-prime numbers. GCD of co-prime numbers always is 1. So we can evaluate by finding the GCD. So that there is no other common factor other than 1. Every number and 1 makes a pair of co-primes. Consider 3, 1 and 3 is a pair co-primes. 1 and 18 co-primes. 1 and 100 co-primes. Because we take 1 and 100, 1 into 1, here 1 into 2 into 5 into 2 into 2, like that I can have. But only the common factor is 1. So if a number is paired with 1, that number is a co-prime with 1. And two prime numbers are always co-prime because prime number have only number and one its factors, and similarly any two prime numbers can always be co-prime, and two consecutive numbers are always co-prime. You take 6 and 7 and 7 and 8. For example, when you take 8, 8 is 2 into 2 into 2, 1 into 2 into 2. 9 is 1 into 3 into 3. There is no other common factor other than 1. So always two consecutive numbers are co-prime. And with the other point, two even numbers cannot be co-prime because they have two as the common factor. So when you have a pair of numbers such that it's 4 and 6, there's no need to evaluate. We can directly say that both are even numbers. Two even numbers cannot be a co-prime numbers.